Welcome to Proactive Task Identification Process Descriptions, and thank you for your interest. We hope you'll take time after this short presentation to explore the other Triad Unlimited presentations on YouTube, follow us on LinkedIn, and visit our website to see all our service and training offerings. Well, the definition of proactive task identification is pretty straightforward. It's just a matter of identifying and implementing proactive tasks that prevent or mitigate the consequences of failure, based on the failure modes that we identified for the assets of a certain priority. The four processes for proactive task identification are selecting proactive task types, selecting proactive task intervals, describing the proactive task, and assigning the proactive task. Of all the asset management functions, proactive task identification is arguably the most important to the bottom line of the business. This is where the actual work that will be performed to care for assets is defined. Just like defining what is an asset defines the scope of the asset management program, defining what is the correct proactive task is defining the scope of the proactive maintenance program. Task identification ensures the most effective tasks are assigned to the most critical failure modes. Task interval selection provides means to ensure high-priority failure modes aren't missed when they are about to occur or are in progress. Task documentation rules ensure technicians have a clear understanding on what needs to be done and how to do it. And task assignment ensures that work is performed by qualified personnel within a scheduled availability window. This promotes high-quality outcomes of task performance. Remember from our review of the P to F curve that we want to manage detection of failure mode occurrence as close to point P, the point at which failure can be detected, as is reasonably possible. Also remember that failure can be introduced by invasive tasks that can disrupt the condition of an asset in the form of infant mortality. So, our task selection is based on that knowledge, and we always try to find tasks in the order they were presented on the P to F curve. Those were condition-based, restoration, discard, and inspection, and failure finding. Also remember that if failure consequences are important, that is, failure mode priority is high, and we can't find a technically feasible task worth doing to address the consequences, we may resort to redesigning the system, asset, or part so the failure mode cannot occur. In this way, we begin to manage potential failure rather than to react to functional failure, and we reap the benefits of that instead of suffering the consequences. Let's talk about task intervals. Please understand that this is not about developing calendar-based maintenance. This is about assigning task intervals based on evaluation of several inputs. First is failure mode priority. And remember, failure mode priority is based on asset priority, the severity of consequences of occurrence on the asset, likelihood of occurrence, and detectability. Next, we want to think about required asset operational status. Can the task be performed with the asset operating, or does the asset need to be shut down to do the task? And finally, the interval factor, the ratio of the task interval to the expected frequency of occurrence. Here's an example decision matrix with these inputs applied. The list on the left represents tasks that can be performed when the asset is in operation. The list on the right represents tasks that can be performed when the asset is shut down. Both lists are sorted based on failure mode priority and then by failure mode likelihood. The proactive task interval factor values for both the lists are higher at the top and then slowly transition down to lower values at the bottom. This means that failure modes with higher priority and more frequent occurrence have the highest task intervals. An organization may process thousands of proactive tasks every year. Managing so many tasks is realistically only possible if there exists a convention for required data and format. By doing this, the task can be managed and processed by software that expects and recognizes the data and format. This is much more accurate and efficient than manually attempting to find, schedule, execute, and close tasks that don't follow any particular rules for data or format. There are many ways to approach setting the rules, but the main thing to keep in mind is the idea of knowing the following information about every task. Who will be doing the task? What is the task? Where is the task assigned? When can the task be performed? Why does the task need to be performed? And how to perform the task, with specific instructions and duration needed. A key step to proactive task development is task qualification assignment. Example task qualification types are mechanical, electrical, pipe fitters, millwrights, HVAC, etc. The final process to proactive task identification is determining how the labor demand will be met in the form of internal and external resource assignment. Classifying the labor demand based on task qualification provides these requirements. These requirements will then serve as inputs to both the technician skills training program and vendor skills qualifications. Each operation has to make a decision on the best internal and external labor allocation profile. Common considerations for determining this allocation are cost savings, staffing flexibility, craft expertise, work quality, personnel issues, tool and technology familiarization, and core business focus. To summarize, proactive task identification requires selecting task types based on failure mode priority, deciding how often to do tasks, documenting tasks consistently, and defining task assignment based on resource qualification and availability. This concludes the Proactive Task Identification Process Descriptions presentation. Thank you for participating.